Hello, welcome to Fun Python Project. In this fourth project, we'll be looking at image compression. I think in a couple of videos in the past, especially on the Python basics, we must have seen some things about image compression. But here, let's take another look at it. Image compression. So we can compress a JPEG image. Uh, so here we look at the quality plus chroma sampling and Gen 2 downscale. So now you see that here we need an input JPEG and then to be returned as compressed. So if you look here, we don't have any document called input yet, but then in the folder for this playlist, I have I have input here. Okay, this is the JPEG. Yeah, this is JPEG inputs, right? And then I have another one for PNG when we get to that point. Okay, so coming back here, so I need to upload the two documents. So I come here, I go to the desktop, come here, then Fun Python project, right? I come here, then I need to pick this up. No, the two inputs, right? This one and this one. So we are going to be working with them. So now it's telling me to make sure I have it saved elsewhere, which is already done. So you can see these two documents are here now. So I can then use them. So for the JPEG one now, so we have, so these are the libraries we need. From PIL import image, from pathlib import path. So the in path, that's the one you're taking in, that's input.jpg. So you put your image here, and then when you're done, this is the compressed image in JPEG. Then the image is image.open in path. Then you convert to RGB, and then so you have an optional Gen 2 downscale. So you can downscale by like 80% of original. So you have WH equals img.size, the img from here. So you now have img underscore ds. That will now be, that's the downscale now. So you have img.resize. So integer, the W here times 0.8. So you are downscaling by 80%. If you want more, you can, just fix. If you want to downscale by 50%, that'll be 0.5. Then for the height also, 0.8 like that. So you're downscaling by 80%. And the image is now lang source. Then you can say with lower quality plus comma sampling 4 to 0, 4 ratio 2 ratio 0 plus optimized of man tables. So you now say for Q in. So you pick different values of Q now. So for Q in 85, 70. So using these different values of Q, 85, 70, 50, 30. Then you can have your output now. So output directory slash F JPEG Q. So you do for 85, do for 70, do for 50, and do for 30. And that's going to be returned as JPG underscore Q 85, JPG underscore Q 70, JPG underscore Q 50, JPG underscore Q 30 on the .jpg. You're going to see all of them by the side. By the way, don't forget we don't have that right now. By the time we do this, you're going to have it. And then you have img underscore ds save out. Then the format is JPEG, quality is Q. So the quality is like 85, 70, and all these things. So quality is key upsampling to optimize true. So done. So if once it's done, it's to say done, check the compressed folder. So I click on this now. So that's done. Check the compressed folder. And so you come here now, you can see the compressed folder will show up in yeah, it's even here. So you have the compressed folder. So you see JPG underscore Q 30, 50, 70, 85. So you can visualize them to see like this. This is 30, then this is for 50, like this. Uh, this is for 70. You may not notice any serious difference, but at the end of this video, I'm going to show you the size of the original document and the compressed ones like that. So that's for JPEG. So how about for PNG now? So for PNG, uh, so we have palette quantize to shrink diagrams and flat color art. So from PIL import image, from pathlib import path, in underscore path is path, the inputs are compressed. So just like before, except that now we are talking about PNG, and then you're converting to RGB instead of RGB. And then here the K is now So try different palette sizes. Lossy for photographs, great for UI slash plots. So for Kane, 256, 128, 64, 32, you also go to have PNG underscore palette underscore 256 underscore 128 underscore 64 in PNG like that. And you save quantized PNGs. So you're going to have 4 of them like that. So you click. So then we can come back here and find the PNG document. So you can see PNG underscore palette 128, 256, 32, and 64 like that. Then if you click on this now, so you can see the compressed document. Now you may not really see any difference like that, but by the time we get to the end of this, you're going to see the sizes of all the of all the files, the original file and the compressed ones like that. So that is for PNG now. So you can see those 4 have joined here. Okay. Now we can also do compression by k-means. K-means is actually a machine learning thing, which if you see my playlist on data science, where I have 60 videos covering all the aspects of machine learning. So we saw k-means there. And k-means is applicable for image compression. So K means color quantization, and it works for JPEG or PNG, and you have good control over palette size. So here you import number as NP. From PIL, you import image from sklearn.cluster, import K-means. So it's good for clustering, right? So from pathlib, import path. So again, we have the input, the JPEG document this time around, and then you output with the compressed one. So you have the image to be converted to RGB. So you have an array because, I mean, by now you should know that in computing, and every image is stored like a matrix like that. So you have array np.array img, you have hwc equals array.shape, then flat equals array.reshape minus 1 comma 3, then choose palette size 16, 32, 64. So k is 32 here for instance. So for k means now you have n number of clusters is equal to k, that's 32, n init is auto, then random state is 0, then you fit flat, then the center as km cluster underscore centers underscore dot as type, np dot ui u input 8, then labels you have km dot labels, then quant you have all of these things. By the time you run this, you have your k means 32. I think only one in this case because the only key we have here is that 32. So this takes a bit of time. Yeah, so that is now. So saved k-means compressed image. So you come here now, you can find the k-means. So you can see this is k-means, and this is how that looks like right here. So you can already begin to see some distortion from the original picture. So like if you look at the face here, you discover that there's a bit of uh distortion on that because of the compression. So we are going to see the sizes later as we go on. So then we have the SVD compression. So that is grayscale, and it is great for demos and teaching. So here the libraries, we need numpy as np, from PIL import image, from pathlib import path, in underscore path equals as usual input and compressed like that. And then here we are converting to grayscale. So we are using the JPEG file, and then you have all of this. K is 50 here, all right. And then you can try other ones like 20, 50, 100. We are doing just 50 for this. So, and here you're using the linear algebra thing where you get the SVD compression from, all right. So what's SVD again? I know I've talked about it in a couple of places. Singular value decomposition, exactly. Singular value decomposition, which you can find in the linalg file, which is under numpy for sure. So, and if you do all this now, you get the SVD compression. Okay, now we have that, and it is in grayscale. So we should look out for that. It should be SVD underscore K. Yeah. So SVD underscore K50. So if you look at it now, you see it's grayscale. That's obvious. It was color picture. Now we have it in grayscale using SVD. So if you want to convert something to grayscale, is like what we call black and white. So having done all of these things, right, can we compare the file sizes quickly? Okay, so here now we have so to look at all the files now. So we look at we have the input for JPEG, we have input for PNG, the original files. So we see the original file size and the compressed ones. So this is the code for all that. So if I run this now, so you can see that for the input.jpg, it was originally 129.4 kilobytes. For the input.png, it was 255.4 kilobytes. So for the compressed files now, you see the the PNG underscore palette 132 gives the smallest size, that is 32.8 kilobytes. Okay, PNG 64 gives 35.6 kilobytes. So if in short, whatever it is, you see that all the JPEG is 129. Okay, I mean, using SVD here even makes the picture big, have a larger size. No, no, no. Yeah, it has a larger size, exactly. Yeah, it has a larger size. So, but you can see for the most part, the sizes are really, they're smaller compared to the original files. So that means that using K-means and SVD are not really the best. But if you use every other method, you see that none of for this JPEG, the highest is 118, which is still below 129, right? So you can see very efficient. The PNG conversion 32.8, 35.6, 44.2. For JPEG, you still have 46.1 somewhere. Yeah, so you have 46.1 and so on. So you can see the compression is real, except for KMIS and SVD that are not so efficient like that. Okay, so with all this done now, we have some practical tips to pay attention to. Okay, so for photographs, right, prefer JPEG. So prefer JPEG tune quality 50 to 85 and keep subsampling to be 2. Then for screenshots and plots and user interface, PNG with palette quantization 32 to 256 colors shines. Then batching, wrap the snippet in a loop over a folder for bulk compression. So like what we did, where we have a 30, 50 and so on. So if you want to do compress over a wide array like that, so you can have it in batches like that. Then visual QA, always inspect a few outputs, aim for the smallest file with acceptable artifacts. So if you look through all the compressed files here, so you can see, okay, if you look at the visuals and everything, so you want to go for the smallest, the one with the smallest size that still has the kind of information you want retained even after the compression. So with this, I come to the end of this interesting project on uh this interesting project on image compression. Okay. All right, so let me know how helpful this is for you. And if there's something you'd like me to try out, let me know. If you have subscribed already, thank you so much. If you haven't, of course, you want to go ahead and subscribe right away. And don't forget to hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can take it a step further. You can become a member of this channel by clicking on join. So you can become a member and have some special privileges and perks attached to that. All right. And more important, like most important, don't forget to comment, like, and share so that more people can have access to the great content I'm going on here. Till I come your way again, keep doing Python right. Bye.